Hi, good morning. How are you? Or good afternoon or happy midnight. I don't know what time you watch these things. Um, this week, we're getting really involved in solving quadratics, which is a huge topic. And I'm hoping that at some point in your math high school career, you've solved a quadratic. We do it in Algebra 1, and then we do it in Algebra 2, and you maybe do a little bit in geometry. It depends on what you were learning. So I just wanted to recap some of those skills because I know that when I make assumptions, you get confused. So hold up, let me get my examples open. All right, beautiful. So there are basically four methods. Two of them are kind of the same, but I want to walk you through all of those really quickly. And then you can ask me if you need any more examples because that's really heavy this week, is graphing these, or not graphing, is solving quadratics. And so I want to make sure that you understand or remember or can recall. And if it means that you don't remember or it's still really fuzzy, ask me and I'll reteach instead of remind. Those are different things. Reminding assumes that you can go, oh, yeah, I just need like a refresher. And reteaching means that maybe you didn't learn it, or maybe it's literally been 3 or 4 years, and so you just need you need every step written out again. So this is just the remind version, and then if you want to, we can do the reteach version. Totally fine. All right, let me, oh, can I do that? Hey, I just made it so I only see myself once because it was distracting me. So, okay, so here's method 1, and these are not in any order. I'm trying to remember what I gave you for the assignment, but it's fine. So method 1 is square roots. Now this method's used if it's standard form with no b value. I totally forgot to do my my intro scene on this. Oops. Or vertex form. Okay, so let's go through those. So let's say that I have a standard form with no b value. I'm going to choose the hardest one possible. Let's do 5x squared plus 11 equals 16. That's not the hardest one ever, but so this is standard form with no b, except the 16 is on the wrong side. So this is the method where you just follow your math heart. You solve it like you would normally solve a problem. So what that means is I'm going to get x alone and then square root it because x will still have the squared on it. So I subtract 11 and I have 5x squared equals 5. I divide by 5, so I get x squared equals 1. I think it's just too zoomed in. It's really fuzzy. There we go. And then I square root both sides. So then I get x equals, well, I know that 1 times 1 makes 1, but also negative 1 times 1 makes 1, so we say x equals plus or minus 1. And those are my two solutions. So positive 1 or negative 1. Whenever I do a square root, I have that plus or minus. This also could happen if I have it a little bit more complicated with maybe some parentheses. So let's say I have 4 times x minus 3 squared plus 1 equals 10. I'm going to, again, move everything to one side. I don't FOIL anything. I'm just going to divide everything over, move it over, get x alone. So I'm going to subtract 1, and I get 4 times x minus 3 squared equals 9. Don't distribute. Just leave this alone. I'm going to divide everything by 4. Now, oops, that keeps the 4 over here, though. We're not going to actually find this answer because 9 and 4 are both really nice square roots. So we're going to keep them separate and just square root both separately. So I have x minus 3 squared equals 9 over 4. And then when I square root, I'm basically going to square root the 9 and square root the 4. So I have x minus 3 equals plus and minus. Again, whenever I square root, I get plus and minus. Square root of 9 is 3. Square root of 4 is 2. So I get that. And then I'm going to add the 3 to both sides. So I get x equals 3 plus and minus 3 halves. Now, honestly, this is a perfectly fine answer, but you might want to actually do the math. So if I do 3 plus 3/2, that's like 1 1/2. I get 4 1/2. And if I do 3 minus 1 1/2, that would be 1 1/2. I had to count down in my head. So those are my two answers. Okay, that's square root method. I'm literally doing all of chapter 9 from Algebra 1, picking the hardest problems and just showing you the samples. So that's what's happening right now. All right, method 2 is complete the square. Now, complete the square serves to make standard form into vertex form. That's the goal. And then from vertex form, we use the method I just showed you. Let me do, again, the very worst problem possible. But usually I only choose this when I have even numbers in the middle. But I will show you the hardest one with an odd number and weird answers. So if I do like x squared plus 9x equals 4. The idea of this is that I have an x squared box, and then I have like 4 1/2 and 4 1/2. So this is a 4 1/2 squared, which is 20.25. Okay, so that's the same thing as we've been doing this week. So I'm going to add 20.25 to both sides. So I get x squared plus 9x plus 20.25 equals 24.25. I know, me too. I chose to do this one, it was my fault. So I have x plus 4 1/2 squared equals 24.25. Now, do you see how that looks like this problem back here without the 1 and the 4? It's this equals a number. So I'm going to basically jump down to this part and square root it. Oops, I got the wrong page. Okay, so then this is where square root method comes in. Which is why I said that that's why I said that there's 4 methods, but there's actually really only 3, because this one is that. So I'm going to square root the x plus 4 1/2 squared, and I'm going to square root the 24.25, which is not a nice number. So I get x plus 4 1/2 equals plus or minus the square root of 24.25. I didn't write this actual number down when I did this for my Algebra 1 kids. Oops. So subtract 4 1/2. So x equals negative 4 1/2 plus and minus the square root of 24.25. Now this is actually a perfectly reasonable answer. If I wanted to, and you can want to, it's okay, I can make this into a decimal and get that x equals 0.42 and negative 9.42. That's a perfectly reasonable answer too. We in Bridge probably prefer to just do the square root. Okay, your call. Method 3. Quadratic formula. Ooh, that got real small over there on the end. So quadratic formula is in standard form only. So it has to be in standard form first. I can write today. Ugh. It's standard form, but I don't know what's wrong with this, why it's so fuzzy. I can post pictures of these too. So if it's ax squared plus bx plus c equals 0, then the quadratic formula is negative b plus and minus the square root of b squared minus 4ac all over 2a. Okay, so that's quadratic formula. I don't know what it is, it's fine. So let's say I have What was one of the gross number? I'll do this one. So if I have my example is negative x squared plus x minus 6 equals 0. I first recognize where a, b, and c are. Oops. B doesn't equal c. Focus. I don't know what's happening. It's fine. So a, see how a was right in front of the x squared? So right in front of this x squared is a negative. So a is negative 1. We don't include the x. We don't include the x squared. It's not part of this. It's just placeholders. B is in front of the x. So b is 1. And c is the last number. C is negative 6. Okay. So we go x equals negative b, which is negative 1. If b was already negative, this would just become a positive. Plus and minus square root of 1 squared minus 4 times a, which is negative 1, times c, which is negative 6, all over 2 times a. And then I just do this math real quick. So I go x equals negative 1 plus and minus square root. 1 squared is 1. Negative 4 times negative 1 is 4, times negative 6 is negative 24. All over negative 2, because 2 times negative 1. So I get negative 1 plus and minus square root of negative 9. Wow, negative 23. This is where I want to like rip this out and start again, but I'm not very good at editing. So I'd have to edit this. All over negative 2. See how this was negative even though I scribbled it out? I can't take the square root of negative. I can. We know we can. Algebra 2 knows that it's an I. I don't remember what we do in bridge. Is that bad? That's so bad. We're going to assume that you can't. We'll say it's no solution. But our algebra 1 version would be that it's negative 1 plus and minus I root 23 over negative 2. Sorry, that's algebra 2. That you might remember. I don't know. That's why I'm doing this. I don't know what you remember. And then I can't do anything else because it's an I. This one has no solution, basically. Last method. I hope that makes that same thought for you. Method 4 is factoring, which I know is not a favorite because somehow in your math career factoring was hard. But we got this. So I factor using x puzzles. In class, we didn't really do that. What we did was remember how we went and we took those boxes, like the area boxes? And we said, okay, well, this is x and x. And all the parts are in here. And then, like, these two had to add up to the middle number. We kind of did this. We did it kind of fast, but we did this. So if I had, like, x squared plus 3x minus 4 equals 0, and I do that method, this is an x squared, so it's x by x. This is a negative 4. So this one is either like a 2 and a negative 2, or maybe a 1 and a 3, or something's negative somewhere. Sorry, 1 and a 4. Goodness. I need snacks. It's almost lunchtime. I got this. The goal here is that these two boxes are going to be something x and something x, so they have to add up to 3x. So if I had like 1x and 4x, and the 1 was negative, that would be 3x. So then this box would be x plus 4, and this box would be x minus 1 from these two numbers. I don't like this method but it might make more sense. I'm going to show you a method that I actually prefer, but let's finish this problem first. So I have x plus 4 and x minus 1 equals 0, and then I make them both equal 0, and I solve it. Subtract 4, add 1, x equals negative 4, and x equals 1. So those are my two answers. I prefer using this thing called an X puzzle, where C goes on top and B goes on bottom, and then the two side numbers have to multiply to get C and add to get B. And I was going to show you this in class, but we didn't get there, and then this happened. So, so for the same problem, I would have negative 4 on top and 3 on bottom, and then I would have to figure out what multiplies to get negative 4 and adds to get 3. Same process. It's not 2 and 2. It'll be 1 and 4, with the 1 being negative. So these are my values for P and Q in factored form. So this is x minus 1 and x plus 4 equals 0, and then I do the exact same math and I get x equals 1, x equals negative 4. It's the same. If you have your preferred factoring method, you can use that. I don't care. I like this one, and it's so colorful. This is my Algebra 1 notes from today. So you can actually go on my channel and watch my Algebra 1 notes, because this is all on there, but it's like the baby down version of what we were doing with you. So x squared in this case has to be 1 x squared, because we're not very good at factoring when there's an a value in front. It's possible. Something you might have actually learned in Algebra 1, but that's the case. You also can technically solve these by graphing them and then finding the x-intercepts. So they're all the same method, because all they are doing is finding when y is 0 and what x is when y is 0. I hope that wasn't too confusing. So I just wanted to remind you of those 4 methods: solving by completing the square, square root method, quadratic formula, and factoring. So otherwise, please email me if you want any more help, if you want me to go through one of these with way more steps. I'm happy to provide for you. So just email me or come to my office hours and I will do this for you. Okay. Have a great week. This drops on Tuesday, so happy Tuesday, or whenever you watch this. Okay, bye.